what I would like to encourage you all to do is to maybe move forward. I know it's like being in church, you want to be in the back pew, but we have a very large room for what is going to be a reasonably moderate audience. So if you would, come forward so we can see you during the Q&A, and we'll start in just a moment. Thanks. Well, good morning again, and welcome to the future of freight mobility. What are the impacts of automated vehicles and connected vehicles? My name is Karen Rasmussen. I'm the President and Chief Executive Officer of HELP Incorporated, which is the public-private partnership that owns and operates the pre-pass truck preclearance system. My role as your moderator today is I want to call it a reality check, to set the stage for our panel by outlining what is going on in the trucking industry today, commercial trucking today, that will have a definite bearing on this topic of deploying autonomous and connected vehicles. When we talk about commercial trucking, this is the mode that, depending on which survey you look at, which study you read, hauls between 67 and 75% of all the freight moved in the U.S. today. And in some states, it's as high as 90%, where they do not have any other way to move freight. So let me just walk through a couple of quick things here. Malcolm told me I had to cut my slides so he could add some. He didn't really say that, did you? This is a pie chart that comes out of US DOT's freight analysis framework. And I don't have a laser pointer on here, but if you can see this, oh, thank you so much. All right. If I point to that, will it work? No. All right. Are you sure? Does it have a battery in it? All right, there we go. I'm not strong enough, that's a problem. All right. More technical, never mind. We can do this. So anyway, if you look at the two pie charts side by side, the one on the left is truck tonnage, or freight tonnage, if you will, and the one on the right is the value of that cargo that is being hauled. And again, I'm sure you can see the legends on the big screen. Trucking has 75% of the tons and 76 point something, if I had my eyes checked, I could tell you, 76.9% of the value of goods hauled today. So while trucking hauls 3/4 of the nation's freight, the vast majority of the trucks that are operating and hauling those goods are in fleets of less than 5 trucks. Now think about that for a moment. The majority of freight in the U.S. today, and we're going to talk about the U.S., is being hauled by trucks that are in fleets of 1 to 5 trucks. By far, the vast majority of the freight. Here is the latest and greatest Seaview truck numbers. And again, I hope you can see those from the back, those of you that are in the back. If you look at the number of carriers by fleet size on the left, you can see that there are 547,000 plus fleets that have 5 or fewer trucks. Correspondingly, there's only 142 fleets that have 1,000 or more trucks. That's a significant thing for companies that are deploying technology, whether it's connected vehicles, autonomous vehicles, or even what is available today in the way of onboard safety technologies. And then if you look at the number of trucks by fleet size, again, you've got a different way of looking at number of carriers and numbers of trucks. But the message is that the vast majority of the freight today is being hauled by very small fleets. This is a new chart that shows the average age of Class 8 trucks. Now let me back up a minute. There are several sources out there that cover the ranges, classes 4 through 8, and they put the average age of the trucks in that fleet size, that fleet range, at 14.6 years. Now, that might seem like a great opportunity for deployment of new technology as these fleets begin to modernize. But this is the number I want you to look at, because Class 8 trucks are pretty much dominate the freight that is being hauled over the road. These are truckload and less than truckload. And you can see that the average age is slightly over 6 years. It went up a lot during the recession. You can see that. These are companies that used to have replacement cycles of like 3 years, because at the end of 3 years, technology's improved, fuel economy's improved, and they want to get those old trucks out of their fleet, and they sell those trucks usually to smaller fleets, which is a good thing, because eventually we will begin to see onboard technologies deployed in smaller fleets as they buy trucks that are sold by the bigger fleets. But in terms of deploying connected and autonomous vehicles today, there's some real barriers. Let me just name a couple of them. Number one is the average profit margin in trucking is between 2 and 3%. Is anybody in the audience willing to admit that that's their profit margin? Yeah, I didn't think so. The current price of a new power unit is about what the mean house costs in Phoenix today, $120,000. So for someone getting into the business, there's not a huge barrier to entry except the cost of the equipment. But you can see that replacing equipment is a very expensive proposition, especially in an industry that's undercapitalized. So, a couple of other things coming down the pike, and then I'll introduce our panelists. There are a number of pending regulations for trucks today that continue to raise their cost. We just saw that there's a couple of onboard safety technologies. There's rulemaking going on that will, again, be mandating certain technologies, and that will raise the price of those trucks, no question about it. There's also kind of a sleeper regulation coming down the pike, and that is the new greenhouse gas rules for medium and heavy-duty trucks, or what we call GHG2. That rulemaking is going to be out this fall, and most of the OEMs, the manufacturers, are very, very concerned about what they're going to have to do, not just to the engine, but to the truck in order to meet those standards, and what is that going to do to the cost of new power units. Last year, ITS America Leadership Circle, the freight startup, in conjunction with Umptree, did a survey of fleets in the US, fleets of over 300 trucks, to see how much technology uptake there had been. And as we had predicted, it's even fairly small among the larger fleets. So opportunity, challenge. So the question for our panelists today: what does all this mean for automated and connected vehicles in the freight industry? What other barriers to deployment and what other challenges are out there, and what is being done to address those? I want to just show you one last thing, and I just love this slide. This is the Freightliner truck that was demonstrated on the Hoover Dam Road last month. First autonomous vehicle, if you will, to be given a license plate by the state of Nevada. Now, Hoover Dam connects Nevada and Arizona, so Mr. Halikowski, I do not know why it was licensed in Nevada. There's also something very funny and odd about this picture. Does anybody know what I mean? Aha. I know something more than somebody else in the room does, which is going to be unusual for today. Since 9/11, trucks have been prohibited from crossing the Hoover Dam. We built a rather expensive new bridge connecting Arizona and Nevada for those trucks to drive, but I guess they didn't have to worry about any other trucks being on there. All right, so let's get on with our panel. Our first panelist today is Malcolm Dougherty. He was appointed by Governor Jerry Brown to be director of the California Department of Transportation, otherwise known as Caltrans, in May of 2012. Caltrans is an $11 billion organization whose 20,000 employees build, maintain, and operate the 50,000 lane miles of California's road system. Director Dougherty has over 21 years' experience with Caltrans, and before becoming director, served as the chief deputy, chief engineer, and district director in the Fresno area, along with a lot of other management positions. His focus throughout his career has been on safety, efficient project delivery, partnerships with all stakeholders, and leading a professional and ethical workforce to provide mobility for the people of California. He serves on a number of transportation-related boards, committees, and commissions. If I read them all, we would have to use his time. Please welcome Malcolm Dougherty.
So where's the remote for the slides?
Green is up, red is up.
Karen, thank you very much, and it's a pleasure to be here, and thank you all for joining us. I'm also very happy to be on a panel with individuals, Karen from HELP, as well as another influential state when it comes to goods movement in Richard Biter, and then also Peloton, who is probably going to talk more technical than I am. So over the next couple of days, probably starting today, there's going to be a lot of conversations about intelligent transportation systems, automated vehicles, connected vehicles, but I don't want to overlook the subject of talking about freight. Certainly that new technology beyond the automated and connected vehicles is going to provide for safety and mobility improvements, and that technology needs to make its way over to the freight industry, because between goods movement and moving people efficiently throughout the state and throughout the country and throughout the world, it has economic and quality of life impacts, and certainly depending on how well or not the freight system is working, it will obviously have economic impacts. I want to give you a little bit of a perspective from California. I probably will identify more challenges than I identify solutions, but I will try to highlight some of the efforts that we are making in California and in multiple states to try to improve upon goods movement and freight movement. For us, it's a significant strain on the transportation system. It impacts the mobility, which then again impacts the economy, quality of life. And another aspect that we are very cognizant of in California is the sustainability of the transportation system. And certainly the goods movement aspect of that is adding to the challenge of sustainability. Sustainability from a revenue, a transportation system life, as well as an environmental standpoint. And ITS, Intelligent Transportation Systems, are going to be part of our solutions going forward. They're going to have to be part of our solution going forward. So this is a little bit of an overview of what I'd really like to cover today. California's role in goods movement and worldwide trade, some of the components of the freight system, from seaports to land ports and border crossings, to the highway system and the rail system and the last mile, whether it's getting to your residence or getting to the store. Certainly want to talk about some broad initiatives that we are considering and working on, and that could be built upon either by folks that are up here on the panel or folks that are in the audience. Again, talk a little bit about the challenges that we face, and then some of the ITS proposals that are underway and are being considered to be able to advance the conversation. To highlight a little bit further about the challenge that we have, in California alone, and this can be rolled up and translated to other states as well as rolled up to a national conversation, we expect our population to grow by a third between now and 2050. We also expect an increase in the weight of goods that are being shipped to increase by 180% by 2040. And you'll see by some of the information I present in a minute, we are having a challenge moving the freight that we need to move today, let alone for that third greater population and increased weight. And we'll talk a little bit about mode shift, what's the most effective way to move it. We'll talk about bottlenecks. We'll talk about friction in the transportation system, which impacts the business model for all those folks. May talk a little bit about automation, but also efficiencies and changes in technology as we go forward. This slide here, we just in California finished an effort to update our freight mobility plan. And what I really want to talk about here is all these different arrows represent the different flows of freight in, through, and out of the state of California. So we have freight moving into the state of California from the rest of the world. We have freight moving out of the state of California to the rest of the world. We have freight moving from within California, originating and ending within California. We have freight coming from the rest of the world into California, going to the rest of the United States, and vice versa. And then we also have freight moving from the rest of the United States to California to get to the rest of the world. This articulates some of the challenges that we have, but it was something that's a very good starting point. You need to know what problem you're trying to solve, what the magnitude of that problem is, and figure out not only the flow of those goods, but then get down into the weeds of the transportation system as well as the logistics go along with moving that freight. This is a picture that I started with on my title slide. This is a bridge referred to as the Gerald Desmond Bridge in the port of Long Beach in California. We have 12 deep water ports in California. 3 are very significant internationally and nationally. The Port of Long Beach is the second largest containerized port in the country. The first is the Port of Long Beach, which is directly adjacent to the Port of Long Beach, and then we also have the Port of Oakland. 40% of all the containerized freight coming into the United States comes through California ports. This is an interesting bridge because we are replacing this bridge at this time, and I'll just tell this quick side story. It is an antiquated bridge. It is a deteriorating piece of infrastructure. We have worn this bridge out. We actually have a net draped under this bridge to catch the falling concrete so it doesn't fall on the ships that traverse below it. The capacity of this bridge, never anticipated the amount of freight that is going across this bridge. 15% of all the containerized freight that comes into the U.S. goes across this bridge. 15% of all the containerized freight that comes into the U.S. goes across this bridge, and we've worn this bridge out. So we're not only replacing this bridge because it's deteriorated, we're also increasing the capacity over it. But another important point is we're also increasing the capacity under this bridge. This bridge doesn't allow the latest generation of cargo ships underneath it, and when we are done, we will have removed that waterside bottleneck as well. So those are important things. I'm going to talk about technology a little bit and maximizing the efficiency of the existing infrastructure, but we're also going to have to talk about expanding the transportation system strategically as well, and that's one example of that. This is an aerial shot of the Port of Long Beach and the Port of Los Angeles. I purposely made the arrow in the middle so small so you couldn't see it, but that points at the bridge that I was just referencing, the Gerald Desmond Bridge, but there is a red arrow in the middle there. But this is the complex of the Port of Long Beach and the Port of LA. The only way California's freight sector is going to be able to continue to be competitive on a national basis, keep the state of California competitive, is to be able to use ITS components and systems across all freight modes and processes. And I'll talk briefly about the processes as well. We need to integrate all those modes to most efficiently move the freight, not just through the transportation system, but also from the ports to the warehouses, to the fulfillment center facilities, and et cetera. And again, we need to maintain we need to be maintaining our competitiveness, not only for California's interest, but for the United States. And this becomes even more and more of an important issue for the state of California as the Panama Canal gets expanded. One way we're going to do that, and I'll call this bottleneck number 1, is at the ports and moving all the goods that are coming in from the international destinations and out to the international destinations and the seaports to distribution centers and to ongoing destinations. One thing is obviously capacity and then the logistics that go along in operating that facility and the complexities of operating that facility. The ITS elements that we need to use are not only on the transportation system, but at the ports and automating those ports and terminals so that we can move the freight as efficiently as we can through those systems. This is a depiction, a rendering of the automated on-dock rail facility that is expected to partially open next summer and to be complete at the Port of Long Beach by 2019. And then it'll be expanded into other ports, including the Port of Los Angeles. But that automation at the port terminal itself is going to increase efficiency. They are also using very green facilities, zero to near zero emission facilities, to not only address the efficiency, use technology to address the efficiency of logistics, but also to use technology to, again, make a headway on the sustainability front. Later on, I will show you a picture. There is one freeway, the 710 freeway, that is the primary corridor other than the rail corridors to serve the Port of Long Beach and the Port of LA, which again are the number 1 and number 2 container freight facilities in the United States. So then you've got other gateways. I'll call this bottleneck number 2. In fact, I'm going to stop calling them bottlenecks. I'm going to start calling them opportunities. So this is opportunity number 2, to remove friction from the transportation system. Mexico is California's largest trading partner. This is the San Ysidro land port of entry in San Diego. It is the busiest land port of entry in the Western Hemisphere. So within about 90 miles, you have the busiest land port between California and Mexico and the 2 busiest seaports for the United States of America, and they both feed into very similar transportation elements of that. In 2013, the value of trade at this land port, the Otay Mesa Commercial Land Port of entry, exceeded $35 billion. The average wait time for a truck to get through this port is about 2 hours. That friction, if you will, costs the region between U.S. and Mexico $7.2 billion in annual economic opportunity or output, which translates into 62,000 jobs each year. So what are we going to do this? Again, strategic expansion, but using new technology also in that expansion. This is a rendering of a new border crossing, which would be Otay Mesa East. But not only will it be more capacity, but it will be intelligent capacity and it will be priced capacity. And we will try to guarantee 20-minute or less border crossings for the trade and trucks in between California and Mexico. Now, how will we do that? We'll use a smart corridor that measures a truck wait time. We'll back up from both ports and we'll provide traveler information to not only trucks, but also to motorists. You can use the Otay Mesa border crossing. Average wait time will be whatever the current wait time is, potentially 2 hours. Or you can pay a fee or a toll to go across the Otay Mesa East new border crossing, and we will guarantee 20-minute or 15-minute wait times, and whatever that wait time is, we'll present that wait time on traveler information in advance of that. So when you'll get to a decision point, you'll be able to cross the border and have an hour-and-a-half, 90-minute wait time, or you'll be presented with the opportunity to pay $25 toll and get across the border in 15 minutes or 20 minutes or less. So there's a lot of opportunity not only for, again, increased capacity, but intelligent transportation solutions here from a priced managed toll crossing, as well as traveler information and the additional technology that goes along with inspecting those vehicles from a security standpoint as we go. So that is one area that we are trying to seize the opportunity to improve transportation of goods through and into Mexico, through and into California, and thus the United States from Mexico. Opportunity number 3, if you will be operational improvements along the different transportation corridors, and again, this would be a multimodal conversation. Opportunity number 4, which I won't get into great detail on, and I think some of the other panel members will be the new technology in the vehicles themselves in moving freight. But certainly, we need to look at opportunities to improve the flow of our corridors and different connectors. And we work very closely with all our transportation partners. I already talked about the local ports and the border crossings, which have international partners, but we also have local stakeholders and local corridors that we need to look at to try to maximize the efficiency of the transportation system. Whether vehicles and freight are taking trucks and vehicles or rail lines is going to be a very important aspect of how we move all these goods. I talked a little bit about how much growth we will all see in the movement of freight going forward, and what is the most efficient mode to move all of that freight. I will show you later on a slide of the capacity that the 710 endures on a daily basis from trucks, and how much benefit would we realize if we improve the capacity of rails and the efficiency of rails. It would also improve the efficiency of those different highway systems as well. I want to talk about a little bit of a coordination, a multi-state coordination. Again, an opportunity to integrate corridors and maximize the efficiency of those corridors. The I-10 corridor between California, our Arizona partners, New Mexico, and on into Texas. We understand the importance of the flow of that corridor, the Interstate 10 corridor, and the goods coming out of Southern California, whether it's the land ports or the seaports, and moving eastward down into the Houston area. It's about 1,500 miles, freight corridor. And in this corridor, trucks, the vision is that trucks would have to be weighed, inspected, permitted, and credentialed once. We also have the opportunity to do truck platooning, utilize connected vehicle technology to save gas, increase safety, increase efficiency, and also I'll talk a little bit about truck parking along this corridor. And the hope is not only to improve the efficiency along this corridor, but also to parlay this conversation on the benefits that this corridor realizes into and the approaches that turn out to be successful into other corridors. When I look at the state of California and a map of the state of California, there are essentially 4 interstate routes to get out of California to the rest of the United States. And I just got done mentioning that 40% of the container freight in the U.S. comes into California. Interstate 10, Interstate 15, which goes up into Nevada and Utah, and then Interstate 80 coming from Northern California, the Port of Oakland, going eastward, and then Interstate 5 north and south makes its way up to Oregon and Washington. 4 interstates for that large state, connecting it essentially to the rest of the United States, accommodating 40% of the container freight. This is a picture of truck parking information. Truck parking is actually a bigger problem than you would think. We want to make sure that we take advantage of traveler information, truck parking information. This is actually a picture of a couple of trucks parked overnight on the side of a connector ramp between 2 interstates. We want to make sure that we accommodate the truck parking not only for safety reasons for the truckers, but also for sustainability reasons, because we can put them in zero to near zero low emission sources. So this is another area of technology that we can provide traveler information for our trucks. Some other broad initiatives that I'll just throw out there. Yesterday we had the opportunity to meet with Congressman Bill Schuster, talked about MAP 21 and reauthorization. We definitely want to talk about a national freight plan as well as a national freight funding program so that we can make sure that goods are moved throughout the country very efficiently. I have even had conversations in California and on the national stage with different ports about a concept called Uber Freight. Maybe I'll give that presentation sometime next year. I also recently had the opportunity to talk to a graduate class at USC about logistics, and this actually refers back to the logistics at the port. They were looking at the logistics between the trailer, the box, and actually the chassis of the truck. And actually those are 3 components just to move the box any distance, whether you're moving it to a distribution center, you're moving it to Texas, you're moving it to Chicago, wherever you're moving it to, and how you organize and logistically handle those 3 components of moving one box. You have the trailer, the box, and the chassis. All right, so I talked about the 710 corridor. This is the 710 corridor. This is a typical day going in and out of the Port of Long Beach and the Port of LA. Now, I talked about the growth in traffic, the growth in goods movement. We're not necessarily handling today's goods in a very efficient manner, and we're talking about growth. If you look all the way to the left of that picture, you'll see where all the cars migrate to because of the volume of trucks. So while we're talking about ITS components and ITS solutions, we have to be very strategic and smart about capacity expansion so that we can also talk about sustainability. This corridor has some significant environmental impacts on the community adjacent to it because of the amount of industrial work as well as truck traffic and transportation that are going through it. And again, this corridor alone today, the volume of trucks is 25,000 trucks a day. We estimate 80,000 trucks by 2035. So you can see what this picture looks like, and we're going to try to triple the number of trucks. We need to think more broadly about how we move and what mode we move traffic and how we move it efficiently. One thing that we're working on, obviously we're looking into how we can improve transportation on this corridor. And here's one concept. I call this 8 new lanes in about 10 feet. That elevated structure, if you use variable lane direction technology, you could actually have as much as 4 lanes going in one direction at a peak time, as much as 4 lanes going in the other direction at peak time, and then you could vary it from 2 and 2 to 3 and 1, however you wanted to do it, and then the columns in the middle of this would be about 10 feet wide. This could obviously be a tolling opportunity. It could also allow for a truck-only facility that would allow for automation and platooning. I talked about the reversible lanes, and we are actually working on a truck platooning pilot in this corridor that may be talked about later in the presentation. But we have to figure out how to do, how to increase capacity on this corridor. Some of this should be a mode shift to railroad. It's possible that we'll talk about trucks that are electrified on this elevated freeway. There's a lot of things being considered, but we have to be very strategic about how we do this. And again, there can be a pricing component as well as a way in motion. Now, my last slide is my stretch slide. I want to try to get you thinking outside the box, and what you see here is a picture of the first commercial spacecraft in history to deliver cargo to the International Space Station and then also bring cargo safely back to Earth. This was not done by a government. This was done by the private sector, SpaceX. I don't know if there's anything we can learn when we're moving goods around this country or around international destinations from freight moving in and out of outer space, but it always seems like we should be stretching our imagination on how we need to move goods, and I certainly will be watching not only how that progresses, but also all the technology that we're going to be talking about in this conference. So I really wanted to show this picture just to kind of stretch your imagination of what we need to be doing in the future. I just got done doing a freight presentation right here, and I didn't even talk about drones. That would be another 20-minute to 30-minute presentation, but that's another growth opportunity or horizon to be able to deal with freight. So I appreciate your attention. I very much enjoyed being here, and I'm glad to be on this panel, and I look forward to answering any questions that you may have on freight mobility and how ITS elements may contribute to the better movement of goods throughout California as well as the country. Karen?
Thank you, Malcolm. Some intriguing challenges, as always. Our next panelist is Richard Biter. Richard is the Assistant Secretary for Intermodal Systems Development for Florida DOT. Rich also serves as Vice Chair of AASHTO's Special Committee on Intermodal Transportation and Economic Expansion. Rich has had a long history in transportation. We were on the phone together the other day and we started comparing notes, and we figured out he actually has been in transportation longer than I have, which is why he has all that white hair. So let me just tell you quickly that Rich served as principal of a Florida-based transportation consulting firm and was also, prior to that, acting associate deputy secretary and director of the Office of Intermodalism at US DOT. He brings with him, as I said, over 30 years of program and policy making experience in the private and federal government transportation sectors. So, Rich, I'm going to turn the podium over to you, and here's your slide advancer, sir.
Okay, thank you. Thank you, Karen. First, I got to say my experience at the U.S. Department of Transportation Office of Intermodalism. I have to give a shout out to my former boss, John Horsley, sitting here in the front row, and he was a great mentor and a great colleague, and we did great stuff together. So, good stuff. And Malcolm, I just got to say, we didn't plan this. We didn't plan this at all, but you could not have made a better segue into my presentation regarding SpaceX, because that's where it took off from in Florida, on Cape Kennedy, or Cape Canaveral rather. I'm going to be talking about the future of freight mobility and the impacts of automated vehicles and as well as connected vehicles, and kind of look at it from the national standpoint as well as the Florida standpoint. And what I'm going to start with, like I do a lot of my presentations, a lot of us don't really realize what's coming at us. I mean, here I'm talking to the front pew in the church, but if we look at the general public, we're looking at a technology tsunami that's coming at us, and it's going to fundamentally change transportation as we know it, and fundamentally change freight transportation as we know it. Okay, we're all familiar with Moore's Law, which is the observation that over the history of computing hardware, the number of transistors on integrated circuits doubles approximately every 2 years, and the price drops about half. And we put together this little slide, this little animated slide, which I love showing because it really brings it home just how fast the impacts of technology is happening. For those of you in the back that can't see, on the bottom is from the year 1900 all the way through 2010. And on the left is the universal adoption of technologies. So you can see where electricity, telephone, the automobile, very slow curves from the time it's introduced, and takes decades before it's universally adopted. But look what's happening. Air conditioning, color TV, look how the arc changes from when it's introduced to when you get universal adoption. Computer. Then we're going to have the cell phone. Look how sharp that curve, I mean, it's almost vertical. And the internet, and the HD TV, and then we're going to get the smartphone. I mean, we went from a cell phone to a smartphone virtually overnight. I mean, I just think, look back, I mean, the Apple iPhone was only invented, 7 years ago? And we're on version 6 now, but how many of us just remember those nostalgic old days where you had that little flip cell phone with a little aerial that stuck out, right? New technology. Okay, but that's the impact of what's happening here. So how does that relate to freight and emerging technologies? Well, and I think Karen did a good job, as well as Malcolm, explaining that the freight volumes that we're going to be facing are coming, and how are we going to address that? Right now, we have a critical shortage of truck drivers. There's currently over 35,000 truck driver shortage, according to the American Trucking Association, and that's going to balloon over the next number of years. There's a number of reasons for that, which gets into another presentation, but the fact remains is that there's not enough truck drivers to move the freight. So here's an opportunity. So we have emerging technologies that could virtually eliminate congestion at ports and connectors. There's going to be challenges with that. And certainly Malcolm talked a lot about the port and the connectors and the importance. I agree wholeheartedly with that. The first and last mile operations could become fully automated. And you think about that when particularly about dray operations. Now, many of you may not have heard what's dray operations. Well, think about the origin of the term is, remember, you all hear about a dray horse, the big, like the Clydesdales and the dray horses. They were what the original Teamsters were. Okay, short haul, taking something a very short distance with these huge horses. Well, the name stuck. So dray operations, where you take something from a port, you drive it within a general circumference of about 100 miles. And that's a lot of trucks going back and forth. And we have congestions on our highways similar to just virtually every state, particularly that have ports. So what are the opportunities with that? And we look at the trucks that are doing that. You look at the trucks that are involved in dray operations, that's where trucks go to die. You see all these trucks on the interstate highways and so forth that, the owner operators, well, once they get past their useful life on the road, it goes downhill, eventually gets in the dray operation. And you combine that with the driver shortage, and we have some critical transportation needs that need to be addressed. So again, we have some opportunities that automated vehicles can provide. And the main thing is, and I'll get into this in a second, regarding the return on investment. Long-haul operations can greatly benefit from truck platooning, and if freight companies can justify the investment, they'll be the early adopters. Think about that. You run a business, and if somebody can come to you and say, look, if you apply this technology to your business, you can increase your return on investment significantly. Okay, you're at that point going to be willing to make that investment for that. And when you look about automated vehicles, particularly in trucks, if you have a fully autonomous vehicle, particularly in a short haul operation, you don't need windshield wipers. You don't need a windshield. You don't need all the creature comforts of a person in there. So there's, again, some opportunities there. And we've seen some, Malcolm talked, actually Karen talked about this, about the Daimler and the Freightliner truck self-driving the big rig over the Hoover Dam. I think there was a small hurricane after everybody exhaled after the truck actually made it across the bridge, but it's still demonstrated. And think about this in our industry of what we're talking about here, tipping points. Okay, we had in our keynote speaker this morning about the Google car, the Google effort and so forth. And, we've been talking about the Jetsons for years and all the but when the Google car actually came out and was run autonomously, there was a tipping point. Joe Q. Public got it. Said, wow, this is real. This is actually happening here. Well, this, I would say, is an example of a tipping point in the freight world. Is that here's an application, here's the technology that works. Okay, and keep in mind too that a lot of the technologies that we're developing for the automobiles, also for the freight industry and vice versa. Enhanced modal operations. Rolls-Royce, not the eventual car maker, but also they make the huge jet engines for many of the Airbus and some Boeing aircraft. Okay, they have started up an operation where they're designing conceptual designs for crewless container ships. The thing is, once you have that ship loaded and it gets out of the harbor, why do you need a whole crew for the thing to go across the Pacific or go across the Atlantic? Just let it go. All right, maintain GPS, have remote sensing and so forth. So they're working on that. We have Freight Rapid Transit and to get there as a company. Automated straddle carriers, one of which is Kalmar is, I think, is exhibiting here at this ITS America. And what I say is that we're going to have disruptive technologies, and that's what these are, disruptive technologies that's going to challenge traditional modal operations. For example, as we get into truck platooning, let's say, and our next speaker is going to be addressing that, Stephen, as we get into truck platooning, okay, we start thinking about, all of a sudden now we're getting trains on highways, okay, that are going down the road. And when we're also talking about automated guideways, okay, think about short haul rail getting involved in drayage operations, which is traditionally trucks. So disruptive technologies means that as we deploy these, you're going to have new types of competitive pressures that trucking companies, railroads aren't necessarily used to, which can be a good thing. Vehicle platooning considerations. Again, our next speaker will be getting into that, so I won't get into the technology, other than to say that platooning, in a sense, have been around for years and decades with respect to the Western railroads, for example. The trains that are going over the mountains, the bigger grades, 1.5 mile long trains, they actually have, 2/3 of the way back, an autonomous engine attached to the train that actually helps push the train as the lead engines are pulling the train to get over the grades. And that's all controlled by a microwave signal. So it's, again, it's happening, but now we're using this technology, a part of this technology, along with other technologies, to use it for truck platooning as it relates to trucks. And of course, there's a lot of companies that are involved in this, but from the state standpoint, is that, and this is our challenge, is how do we oversee that? How do we ensure that what these companies are projecting or what they're saying, that, yeah, we're going to guarantee that the heavier truck is going to be in the front, not in the back, so that when that lead truck stops, the rear truck's not going to plow into it? Okay, they can say that, but how do we know, how does the state know that that technology is there, and what certifications do we need to have? In turn, how do we as individual states work together in devising, in looking at our motor vehicle laws to ensure that when we have a truck platooning operation that we approve in Florida, that it doesn't get stopped at the Georgia line and say, no, you can't do it. So that's where we start working with the I-95 Corridor Coalition, for example, to ensure that whatever we're doing, let's all come to an agreement, and let's not make the mistakes or the sins of the past. And I got 2 words for that: electronic tolling. Okay, electronic tolling came out. Wow, isn't it great? Got a transponder in the car, I can go on to the thing. But all of a sudden, hey, wait a minute, my pass doesn't work in Georgia, or my pass doesn't work in New Jersey. Every state came in and had a different thing. Now, a lot of blame on that, individual state rights. States have different funding sources. A lot of different consultants get involved, and they want to say, hey, my system's the best. Okay, let's partner and do that. So you had a lot of companies that got together, a lot of states that got together or didn't get together and devised their own systems. We're now trying to make up for it. Map 21, for example, has a provision in there that all states have to have, that all tolling systems, interstate tolling systems, have to be on the interoperable with each other by the end of 2015. Ain't gonna happen, okay? Not gonna happen. So, but here, what we have is, let's not do that mistake in the past. Let's be on the forefront of this, and I give kudos to the U.S. Department of Transportation, who invited several of us states, California, Florida, Pennsylvania, Nevada, the District of Columbia, invited us in 2 weeks ago to sit down and talk about what the states are doing and get, a real back and forth conversation of where we need to go forward, so we don't, or so that we, as we go forward, we are making these investments, and we're not going to be doing something where the beta versus the VCR. So. Okay, more considerations, again, the need for federal motor carrier safety get involved. Does it involve hours of service and so forth? Do we need to, again, look at that? But again, this has promise also, not just in trucking, but also to think about transit, using platooning in the transit end. Truck parking, Malcolm mentioned that, big issue in California, huge issue in Florida. We have 15 ports, and we have trucks going there, and it becomes a huge safety issue. Again, we have public parking spaces in our interstate rest stops, but they get full, and guess what happens? They park on the shoulders, and they park anywhere they can just to get off the highway, because the parking is not available anywhere else. So, and then our law enforcement, if they knock on the cab and say, you got to move this truck, guess what? The law enforcement officer's telling the driver now to break the federal hours of service rules, because that driver can't legally move that truck. So again, we need to work this out. We are going to be investing over the next several years in Florida in developing and outfitting each one of our rest stops and our way stations, which were originally built with extra capacity for parking, that we're going to be putting technology in these to identify every spot that's available. So, and be able to make that available, what I would envision as free service to the private sector, so that just like we have developed a partnership with Waze, that we feed them our construction sites and road closures and so forth, that we would partner with any private sector to give that information out, to let the ultimate user know what's available as far as parking is concerned. So it'll all be connected and ITS related, and hopefully, in essence, developing a trucker's 511. Yeah. And this is just a quick freight application of what we're doing, a pilot project in Florida involving the Miami International Airport and flowers that are coming. 95% of all the fresh cut flowers coming from Central and South America come through Miami International Airport. And there's a lot of dray operations coming near and around Miami International Airport, so we're working with these companies as well as the airport and the county to figure out ways to apply automated vehicle technology in that arena. Of course, there's always land use impacts. When we change how transportation is used, we could end up freeing up a lot of land that is formerly dedicated to other uses. And finally, just a quick plug, we have our third annual Automated Vehicle Summit's coming up this December in Jacksonville, Florida. And we look for that to be, again, a hands-on showcase of what we're doing in Florida as far as automated vehicles are concerned. So with that, I'm happy, again, thank you for the opportunity to be here, and I look forward to answering any questions afterwards.
Thanks, Rich. Our final presenter today is Stephen Boyd, who is the co-founder and vice president of external affairs for Peloton Technology. He has managed organizations and campaigns in the energy, transportation, NGO, and government sectors for 20 years. He has served as an assistant press secretary in the White House, producer reporter at the PBS NewsHour, and in a range of other roles with national political campaigns, federal agencies, and noted policy initiatives. He holds an environmental science degree from Pennsylvania State, almost back home, and he was a co-founder of the Clean Economy Network and serves on the boards of several organizations to improve support for entrepreneurs and at-risk youth. So please welcome Steve Boyd.
Great, well, thank you, and it's great to be back here in Pennsylvania, and I want to thank ITS for having me be part of this discussion. I know we want to make sure there's some time for questions, and is that our time limit? Okay, so what I'll do is I'll keep my material short, and so there can be more dialogue, and what we wanted to do was talk a little bit about what we're doing at Peloton. We think that a key way ahead in improving freight mobility and efficiency and safety is around connected trucks, bringing together partial automation in the near term to augment the abilities of drivers and improve the safety of vehicles, and then an appropriate multi-lane divided highways managed by our Network Operations Center allow for platooning. So what I'll do now is turn to a video, and the guy in back's going to cue this up because the system wasn't working, I think, otherwise. Here we go.
Our platooning system improves the safety and efficiency of trucks by using advanced sensing, communications, and data. You can think of it like cruise control, but we do it for a pair of trucks. Our cloud-based network operates.
Whoops. All right, maybe not. Well, we'll see if he can work on it. I'll just keep going here. We use a lot of Apple products, and they don't seem to be compatible back here right now. Okay. So, platooning's been going on for over 20 years. There's work going back to the 90s by the California PATH program, a lot of leadership by California in that regard, and around the world, both over the last several decades and now underway in several countries is a whole set of new activity in the Netherlands, Sweden, European Union, specifically a joint project across the EU, United Kingdom, and other sites as well. So I think we're also facing a situation where the U.S. needs to show some leadership here in actually catching up with other parts of the world. We have a Silicon Valley-based team with deep experience in vehicle safety and control. I won't go into that so we have time to talk. And a strong board of directors, including Rodney Slater, former Secretary of Transportation, Ralph Eschenbach, one of the early developers of GPS applications for transportation, Mark Lydon, the managing director of the Internet of Things initiative for Intel. Recently, we brought in a new set of great investors, including Intel, Volvo, Denso, Lytix. Castrol Ventures had been on board and invested further, Magna, Lockheed Martin, and we've also received investments from Nokia and UPS Ventures. So we're working to tackle the major pain points in trucking as an effort to leverage efficiency to deliver safety. As Karen pointed out from that great study that was done, there's a real problem with cost barriers for fleets to introduce safety systems on trucks. But these great safety systems are available and should be deployed. We think our approach can help deploy those safety systems faster, improve the safety of individual trucks everywhere, starting with the large fleets, since the economics require that, and then moving forward to improve the efficiency and safety of fleets more broadly. So our goal is to enhance fleet economics and improve safety, since those are integrally tied together. So we work by connecting trucks, but start with the individual safety of each truck. So we integrate with the leading braking and safety system suppliers to provide the state-of-the-art collision avoidance systems. These are always on, making each truck individually safer all the time. Our cloud-based system enhances that with alerts and monitoring. And with our vehicle-to-vehicle communication systems, we're also working to leverage the power of networks between vehicles and ultimately between infrastructure as the V2X network builds through leadership by folks like here and all of you. Then on appropriate multi-lane divided highways, as I said, we're able to link pairs of trucks together and use the V2V to sync that braking instantaneously so that the gap is maintained with a 1/100th of a second precision. The gap following distance is regulated by conditions and the particular vehicle characteristics, including our cloud-based system intelligently ordering the trucks based on weight and braking ability, coordinating and matching trucks, and geofencing out so that only appropriate areas, appropriate roadways are where platooning can occur, and based on driver and truck condition and performance. Trucks that are not in good condition, drivers that are not suitable or have not been performing well are not able to platoon. This whole suite of sensors and information about the vehicles and our use of the cloud to monitor and manage them also leads to new and higher levels of contextual data that's of benefit to many parts of the system, fleets, drivers themselves, and highway operators. A key part of our system is increasing driver awareness of the road by sharing video between the front and back truck, providing the rear driver with a view ahead of the road and the front driver with a view of his blind spots. This shows a bit more about how linking trucks and syncing their braking can actually improve braking ability between a pair of trucks versus the status quo today, where trucks follow often too closely, have no information about the relative weight of the vehicles around them, and are manually unable to brake in time. Human braking, partially automated, where a single vehicle has a adaptive cruise control system, for example, with braking, and coordinated where the vehicles are connected, and instantaneously a braking signal goes from the front truck to the back truck. We have done a set of independent verifications on fuel efficiency, including these two sets of evaluations by NACFE and NREL. Those showed 10% fuel savings on the rear truck, 4.5 on the front truck, and strong savings even at 75 feet. The U.S. freight network, you're all very familiar with it. Platooning would be principally aimed at multi-lane divided highways on the key freight corridors where conditions are appropriate. Trucks are out there to get today in large numbers together, and many fleets are very interested in what we're doing. We have 18 fleets interested and lined up to hold trials, and they have all said that they are able to alter their dispatch and coordination to allow groups of trucks pairs of trucks to work together in platooning on many of their corridors. So we've talked about the knock and some of the elements of it. The benefits include data of value to highway operators, drivers, fleet managers, and these data sets are useful through the DOTs to share with motorists, to share with the public, and improve overall highway safety in a granular level around weather, traffic conditions, accident patterns, and other things like that. To make the economics of platooning work for fleets, due to their razor-thin profit margins, we're providing platooning as a service, allowing a minimal upfront cost, and these arrangements can be adjusted to fit larger or smaller fleets, so that smaller fleets ultimately could face almost no upfront cost and through shared savings get the ROI quickly in under 2 years, under a year even, a key issue for fleets. Our work with delivering the systems includes working with the truck OEMs, the braking systems suppliers, and the fleets, and we've already got a number of efforts underway leading towards pre-delivery installation and even OEM integration. At the government, across the government picture, at the federal level, there's no rules that limit platooning, close following. At the state level, as was referred to, some states have specific numeric following distances for commercial vehicles. Many do not, most do not, and there's a reasonable and prudent standard for conditions that can be looked at as we discuss with states how to make these systems work when you have an appropriate system that enhances the safety and performance of the vehicles at a closer distance. Work with a number of states to hold trials via either administrative approval or legislation, and we have funded projects underway with all of those agencies at the federal level. 2 of them, notably one with Caltrans, we're a member of that team, and with Auburn, focused on best practices and pathways to early deployment of platooning. So we're collaborating across the key industry groups, including the ATA and the TMC, a task force there, SAE through the various standards committees, and we've worked with a number of states on past demonstrations, Utah, Nevada, Michigan, and we're now setting the stage for fleet trials going into 2016 with administrative approvals already in place in Texas, Nevada, Michigan, and Alabama, legislation passed in Utah, and legislation in consideration and in process in California and Florida. There's high interest in discussions with a number of other states, including those there, Missouri, Wisconsin, Iowa, Tennessee, Arizona, and others, and we look forward to ongoing efforts to do more with this. So thank you for your time, and love to turn to questions.
We are running a little late. We have about 5 minutes for some questions, so make them good. Questions? Everybody wants to go to lunch?
Can I ask Steve a question?
Absolutely.
No, I'd love to hear a little bit more about, in the platooning, how many trucks maybe Peloton envisions being able to platoon, and whether or not it would have to be on a designated truck route, or whether or not we can get to a point where we can safely integrate them with other automobiles.
It's a great question. So our focus is on pairs of trucks and limiting platooning to just 2 trucks at a time. We think that from a vehicle dynamics sense and also from a public operations sense makes the most sense. It presents a less of a barrier or a perceived barrier to other traffic. Now, one thing I should note is that the system allows for vehicles to cut in between the trucks. So you could have a longer chain ultimately, and a number of other projects have demonstrated this, where vehicles can pass through that chain of vehicles with the vehicles parting smoothly to allow that exiting or entry of a vehicle, for example, from a ramp. We're focused on pairs of trucks because we think that's the right size of a vehicle package to start with. On appropriate corridors, perhaps down the road, there could be longer chains. In terms of what types of highways and roadways this applies to, we think that low topography, multi-lane divided highways where traffic conditions are appropriate and weather can be suitable. In our Network Operations Center, although I speeded through this and the video didn't get to show this, our NOC focuses on approval of platooning based on weather, road conditions, truck and driver condition, and things of that nature, and traffic.
Did everyone hear that question? The
Aye.
question was, does Peloton envision tying in the National Operations Center with State Operations Center?
Yes, most definitely. We're very interested in continuing dialogue as we work with key states like Florida and California on how to best tie in key data. Sharing of data is crucial. For example, where are the construction zones? What are the known traffic and accident patterns? What are some of the other issues? More granular weather data can be provided, lane level traffic data. There's a variety of sets of information, and so we definitely are excited by that ability to provide benefit to the public system.
I have one question, which is more of a public policy question, I guess. Given that for 30-some years or longer now, what are called longer combination vehicles are being operated in a number of states. New York Thruway, I think, started the trend way, way, way before even the western states. But there's always been huge opposition to expanding those types of combinations, both from safety groups and from the railroads. So how does truck platooning fit into that bias, if you will, against longer vehicles on the road or truck trains? Who wants to tackle that one?
Well, from an owner-operator standpoint, it's kind of an intuitive, not necessarily a known factual answer, but there is a little bit of a hesitation by the general public to have the triples and things like this. I would imagine that this provides not only to the operator and the goods mover some more flexibility, but as long as I think that it'll be a little bit easier for public acceptance. I think our biggest concern as an owner-operator, and I kind of knew the answer to the question that I asked, but I wanted to get that conversation out there, is if you the platooning and you get that train effect. Trucks operate generally in the slow lane, and that's where the on-ramps are. And we wanted to make sure, and I think Peloton is working with this as well as other operators, that you're going to be able to merge in and off and you're going to be able to do it safely. The general public may not realize that vehicles are platooning in this respect, and then there would be a little bit less of an intimidation factor than the doubles and the triples maybe.
Okay, we have time for one more question. Sir.
The fuel savings that come with truck platooning are substantial, and that rolls directly into reduced air pollutant emissions. So how do we get the air quality management districts to put truck platooning into their scenario planning for their air quality management plans?
Good question.
Well, I would say, first off, in other words, you have to, right now, it's pretty much in a pilot stage. I mean, once it's proven technology and it's actually happening, at that point, I think, that's when action would be needed for them to get involved. And also, I think the jury is still out as far as, the applications for truck platooning. In other words, if you're looking at an urban area for air quality versus looking at a region, it's going to apply much more to a region as far as platooning is concerned, as opposed to a within an urban area. It would be my guess on that. So
Yeah, and I'll try to expand on that. The regions in California are responsible for coming up with sustainable goods movement strategies and sustainable communities and reducing NOx and greenhouse gases. And I think since it is in the pilot stage, I don't know that they can quantify on a grand scale yet. But I think if they really work strategically, this may be one of those components that can help them get there, because they're struggling to figure out how to get there. They're talking about electrifying vehicles, which is going to be an expensive proposition, and if a fleet turnover issue. If you can actually realize those emissions and fuel efficiency measures by doing platooning, and it becomes a fleet-wide measurable as opposed to a couple of trucks measurable, I think that they would be wise to start to incorporate that in there as best they can. Now, of course, we're still working through the pilot stage and the regulation stage, the legislative stage, to be able to do it, and I think that'll be a critical step to be able to accomplish the benefits.
I would just add that we're excited about that area. I know we're probably out of time here, but we think that our NOC-based system is able to monitor and show the data as far as savings. And when we get that 10%, average 7% savings in some settings, that's a reduction in fuel burn. So that's a GHG reduction for sure. And we're working to optimize how the system addresses emissions in general. There's no question that as we work with the California Air Resources Board and the CEC and others, there's a great opportunity here. There's those ambitious goals that the governor of California has set out for GHG reduction and emissions improvement. And long corridors like Sacramento to Bakersfield have emissions issues from a health standpoint that can be tackled.
All right, well, would you join me in thanking our panelists again? And I'd like to thank all of you for your time and attention and for sticking with us for just a few minutes past our deadline. So have a good rest of the conference. Thanks.
Very good, Karen. Thank you.